Related conditional statement. First, let's define what is a conditional statement. In mathematics, an if-then statement is called a conditional statement. The if part is said to be the hypothesis, and the then part is said to be the conclusion. We have three related conditional statements: the converse statement, the inverse statement, and the contrapositive statement. The converse of a conditional is formed by interchanging the hypothesis and the conclusion. The inverse of a conditional is formed by negating both hypothesis and the conclusion. For the contrapositive statement, it is formed by interchanging the hypothesis and the conclusion and negating both. So let's have the summary. So we have the types. We have the conditional, converse, inverse, and contrapositive. So our given is the conditional statement. It is in the form of P, then Q, where P is our hypothesis and Q is our conclusion. For the converse, we interchange or switch the hypothesis and the conclusion. So if we have P then Q, we interchange or switch. So we will have in the form of Q then P. So that is our symbol for converse. For the inverse, we negate the hypothesis and the conclusion. So negating P, so we have not P, then not Q. For the contrapositive, we interchange or switch and then negate the hypothesis and conclusion. So we switch the conditional statement P then Q, it will become Q then P. And then we get the negation of Q then P, so we have not Q then not P. A conditional statement and its converse are both true, or when a conditional statement and its converse are both true, it is said to be a biconditional. A biconditional is in the form of P if and only if Q. Logically equivalent statements are two statements that have the same truth values for every possible interpretation. The conditional statement is logically equivalent to contrapositive. The converse and inverse of a conditional statement are logically equivalent to each other, but neither converse nor inverse is logically equivalent to the conditional statement. So later on, we will discuss what is or how can we form biconditional and also the logically equivalent of the related statement or the related conditional statement. First, let's have a review. Our given: if you are studying at Bimapa High School, then you are a public school student. Let's have identify first the hypothesis and the conclusion in the conditional statement. So our hypothesis, you are studying at Bimapa High School. That is our P statement. And the conclusion will be you are a public school student. And that is our Q statement. So to write the converse, we will have Q then P, or switching the hypothesis and the conclusion. So the converse will be if you are a public school student, comma, then our P statement, Q then P, then you are studying at Bimapa High School. So that will be our converse. For the inverse, we have not P, then not Q. So we negate the P statement and we also negate our Q statement. So the inverse will be if you are negation not studying at Bimapa High School, then you are not a public school student. So that is our inverse. For the contrapositive, so we have not Q, then not P. So this is our Q statement. Negation of Q statement, then negation of P statement. So we start from the negation of Q statement for the contrapositive. If you are not a public school student, then you are not, that is our not P, not studying at Bimapa High School. So that is our conditional and its related statement. Now let's identify the truth value of each statement. Let's have first the conditional. If you are studying at Bimapa High School, then you are a public school student. So this is said to be true statement because all students studying at Bimapa High School are called public school students. Next, for the converse, if you are a public school student, then you are studying at Bimapa High School. So we all know that Bimapa High School is not the only school or a public school, not only a public school. Therefore, this is said to be a false statement. Our counterexample for that is we have the Claro M. Recto High School that is also a public high school. For the inverse, if you are not studying at Bimapa High School, then you are not a public school student. Again, suppose you are studying at Claro M. Recto High School, you can also be called as a public school student. Therefore, the inverse statement is said to be false statement. For the contrapositive, if you are not a public school student, then you are not studying at Bimapa High School. So, this is said to be true statement. Why? It is true statement because, again, all students studying at Bimapa High School are called a public school student. So those are the truth value of the conditional, converse, inverse, and contrapositive. So as you can see, for the conditional and the contrapositive, we have the same truth value. And for the converse and inverse, we have the same truth value. So those are the logically equivalent. So the logically equivalent of the conditional statement is the contrapositive. And the logically equivalent of the converse is the inverse statement. So we can check more if it's true to our next example. Let's have the converse, inverse, and contrapositive. Conditional statement. If a figure is a circle, then it is not a polygon. So let's identify first the if statement. So a figure is a circle, that is our P statement. It is not a polygon, it is our Q statement. So even though it have not as a word in a statement, it is also a Q statement because our symbol for conditional is P then Q. Next, it pertaining to our noun of a figure or our subject figure. So to write the converse, Q then P, we have if a figure is not a polygon, comma, then it is a circle. So that is our converse. We interchange the hypothesis and the conclusion. Next, for the inverse, not P then not Q. So we get the negation of P. If a figure is not a circle, so not, we indicate not for our P statement, then it is, so negation of not is a positive, it is a polygon. That is our inverse. Next one, for the contrapositive, not Q, then not P. This is our Q. So to get not Q, if a figure is a polygon, that is our not Q because our Q is not a polygon. So to get not Q is a polygon. Then it is not a circle. So that is our contrapositive. Now let's have the truth value of each statement. So first, let's define what is a polygon. So a polygon is a figure. The sides of the polygon should be a segment. So since a circle, this is a circle, it is round, therefore it is not a polygon. So that will be true statement. So a figure is a circle, then it is not a polygon. For the converse, if a figure is not a polygon, then it is a circle. So that is said to be a false statement because we can also have oval as our counterexample. Oval is also not a polygon. Likewise, for the inverse, if a figure is not a circle, then it is a polygon. This is a false statement because we have a counterexample of an oval. Another one is a figure with a curve. If we have a curve, that is also not a polygon. Next, if a figure is a polygon, then it is not a circle. And that is true statement because circle is always not a polygon. So as you can see, the conditional and the contrapositive have the same truth value, and for the converse and inverse also have the same truth value.